What up, Warhawks? Mr. Martin. We're going to be going through 4-6. It is using the volume formula. So we've been talking about volume for a couple different shapes. We're going to kind of put it all together here in 4-6. So number one, a standard size sheet of paper measures 8.5 by 11. That's just your piece of notebook paper. Use two standard size sheets of paper to create two cylinders. One cylinder should have the height of 11 inches. The other cylinder should have the height of 8. So one you're going to be kind of folding like they say hot dog ways, and one you're going to be kind of forming a cylinder doing a hamburger. So that kind of to give you a picture of that, you would have one, and this would be 11 inches, and you'd have one, and this would be 8. Okay, so alright, so determine the radius and the height of each cylinder without using a measurement tool. So if I was going to do the one where I had the 8 is my going to be my height, that means that my top, my around, would be from one side of the paper to the other. So if it was 8 high, the circumference of the circle would be 11, and that would be all the way around. Well, in order to find my radius, I would use my circumference equals 2 pi r. We've been dealing with this a little bit in class, and so I would put my 11 here, and that equals 2 pi r. And now I'm going to be working backwards, so I'm going to divide by 2 pi, and I'd use a calculator, and when I use my calculator, my answer is 1.75, and that would be my radius of this type of thing going on. So that would be my radius. Now if I do the other one, I would have a cylinder that would be, now instead of being 8 high, it would be 11 high, and then when I did my circle up here, hopefully you realize that circumference would now be 8. And so my formula would now, because there's two problems here, doing one for each different cylinder. So I would take that and I'd go, okay, now 8 equals 2 pi r. Divide by 2 pi, divide by 2 pi, and I get the radius equals 1.35. So obviously, the larger the circle, the bigger the radius. The smaller the circle, the smaller the radius. So now we're going to go ahead and go down on this page over here. Sorry, one second. Alright, so now we're going to find the volume. Well, in order to find the volume, we had to have those radiuses, so a radii. So we got those. So now we're going to find the volume of each of these different cylinders. So volume equals, okay, the volume formula was for a cylinder, pi r squared times h. That's the, again, this really stands for the big B that we did in that formula. So we got that equals pi times the radius, which was for our first one, 1.75, and you're squaring that, and then times by 8.5, because that was my height. Okay, so that's a squared, 1.75 squared. When you do this in your calculator, you're going to get 81.74. So you should have squared this first, multiply by 3.14, then multiply by 8.5. That should get you that answer right there. Alright, sorry about that. Some crazy things going on. Alright, so then I'm going to do the volume equals, again, pi r squared times h. Again, this is still representing my big base for my prism formula, but this time it's going to be pi times, and then my radius was 1.35 squared, and then my height is 11 here. So when I multiply that, I go ahead and I get 62.95. I put that in my calculator. You should check to make sure you can do that in a calculator correctly. So if you notice, the one with the bigger radius equaled more volume versus the one that had the smaller radius got a smaller volume. So if you look at that, you can realize that the radius, because it's squared, because the radius is squared, it's going to have a larger effect on which one is going to be a bigger volume. So moving on. We're going to determine the approximate volume of this vase. So what we're going to realize is here, we don't really have a volume shape for this, for this type of shape. So what we're going to do is we're going to say, you know what? If I take that shape and I cut it into two different sections, if I cut it right here, okay, that's going to be 6 inches high, and this will be 6 inches high. Okay, so if I take that and I say, you know what? Let's do a cylinder on the top. Let's do a cylinder on the bottom. Sorry, my pen is off. And let's say that this right here, we're going to do a radius for this cylinder. Since it's between 2 and 3, we're just going to split that and make it 2.5 for our, and that's our radius. Sorry, my pen is way off. So that's the radius of that. Then for this bottom one, since we go to 2 to 4, we're going to say our radius for this one will be about 3 inches. Hold on, let me arrange this board again. This is not good. All right, hopefully that'll be better. So, again, let's try to draw these out. So if I have a cylinder, there we go. My radius up top would be 2.5. I'm splitting the difference between these two guys. Okay, and then my bottom cylinder is going to be split between 2 and 4, so it would be a radius of 3 inches. Okay, and then it's still going to be 6 high, 6 high. If I wanted to do the approximate volume, what I do is I would do two volumes. So the volume of a cylinder is, again, it's pi r squared times h. I'm going to do that twice. Once for the top part, for this half, once for this part, then I'll add them together, and that's going to be my approximate volume. So if I take that and I go, okay, that's pi times 2.5 squared times 6, and that is going to equal, when you put that in your calculator, that will be 117.75. And then if I do the upper one, I get volume equals, again, pi r squared times h, pi times 3 squared times my h, which is 6 again, and that equals approximately 169.56. And then in the end, I would add those two together, so I would take 117.75 and add the 169.56. And when I added those together, I would get 287.31. And that would be my approximate value, volume of this vase. Remember, I did it in two sections. I did the upper, I approximated it to be a cylinder like this. I took this one, I approximated it to be a cylinder of that, added those two values together, and that's how I came up with that final volume. All right. Our final question for today is going to be a hot air balloon. It's about 75 feet tall and about 55 feet in diameter at its width. So for this right here, we've got that it's about 75 feet tall, and we've got at the widest right here is going to be 55 feet. So about how many cubic feet of air does this typical hot air balloon hold? So I'm going to go ahead and move this down a little bit. Extend this page for us. All right. So here we go. If I take this top half, if I take the top half of balloon, hopefully you can see that kind of looks like half of a sphere. And then the bottom kind of looks like a cone. So what we're going to do is we're going to split this into two different formulas. We're going to figure out half of the sphere. So we'll talk about that in a second, what formula I'm going to use for that. And then we'll talk about the volume formula for a cone. And then we add those two together. So we're going to do two problems again to figure this out. So, all right. So the volume of a sphere is normally 4/3 pi r cubed. But I only want half of that. So essentially, if I take this and I times it by 1/2, because I only want half of that volume. I don't want the whole volume of the whole sphere. I'm only taking half of that. So then you see, hopefully, that this 1/2, I can actually erase these parentheses since it's all multiplication. And I can say 1/2 times that 4/3. Hopefully you see these cancel out. What I end up with is volume is going to equal 2/3 pi r cubed, because this is going to be, this is for half of a sphere. Okay, so I'm only doing half of the sphere. So then I take this and I go, okay, they did not give me my radius. They gave me my perimeter, or they gave me my diameter, which the diameter was 55. So in order to get my radius, I divide that by 2, and I realize that my radius is going to be 27.5. So now I can just pop this in, 2/3 pi times 27.5, and that is cubed. And when I pop that in my calculator, I get that the top half of this is going to hold, it's going to be a very large number. It's 43,556.87 cubic feet. That's feet cubed. Now that's just the top half. That's this section right here. We'll hold that. Now I still have to do this cone. So now I go down and I go, okay, I got some more work to do. And so that's, let's go ahead and extend this page a little more. And now we're going to do our next part. We're going to say, okay, now for the cone. Well, hopefully you remember that the cone formula is going to be, it's going to be a little bit more tricky, because we have to do, volume of a cone is 1/3 times pi r squared, and then that's the b, so 1/3 times big B times h. So I got to figure out that h part. And I already have my radius. I need my h. So I look back up here, and I said, okay, here's where it becomes a little tricky. In order to figure out how much height this was, that would be, see, that's the center of my circle. So that's going to be the length of the radius. So I would not be splitting this 75 in half, because the radius is not half of the 75. Remember, the radius was the 27.5. Well, remember, that radius is going to be here, but it's also going to be here. So my distance, I know it looks like it's in the center. That picture is just a little off. If I want to find the actual height of this cone from here to here, I would take 75 and I'd minus that 27.5, and then I would realize that my height is really 47.5. That's how high this cone is from right here. It would be that value. Okay, so I know there's a lot of stuff going on up here. I hope you're following along with what I'm saying. That has to do with this being the radius. Not only would it be the distance from here to here, it'd also be that distance. So I had to take the 75 and subtract the radius, which was 27.5. All right, so I got my height now. I'm just ready to rock and roll. 1/3 times pi. My r is still going to be 27.5. So 27.5 squared times, and I just figured out my height, which was 47.5. I would square this first. I'd multiply by pi. I divide it by 3, and then I times it by 47.5. All of that in a calculator. And I would realize that it's going to hold 37,000. Sorry about that. 37,617.3 cubic feet, or feet cubed. That's only my bottom. In order to figure out how much the whole thing would hold, I would take the 43,556.87 and I would add it to the 37,617.3. And when I add those together, you get a total of 81,174.17 feet cubed. That's a good approximation of how much that hot air balloon would hold. Hopefully you're seeing that this is kind of like what we talked about when we found the area of irregular figures. We could just kind of piece it together and take different volumes of different shapes, because like we said, we cut this one into half of a sphere and a cone shape. So hopefully you're seeing that. If you have any questions, make sure you hit us up. Sorry it took a little bit of time on that one. Kind of putting it all together. Hope you have a great night, and I'll see you tomorrow in class.